Hello everyone, it's July 30th. Let's do this. Oh, by the way, I finally started to at least set up Golang. Not on this laptop, but on my other laptop. Set up the NeoVim side of the things. It'll take a while, but I think I can get it done. I think I got the LSPs done. LSPs using a Go please, right, for LSP. And I didn't I don't I mean I was going through some tutorials on the YouTube, and some of them don't even use linter. So I think Go please, the LSP probably has linting capability already. So it was not the linter was not part of the setup. So I'm not setting up the linter. Formatter is interesting. So we have the Go fumped, right? And Go lines, Go fumped. What's the other one? Go sorts, Go imports, Go import revisor. So that's what I set up today. There's still the debugger that I need to do, so I'll probably do it tomorrow. And also just starting to read a little bit of kind of the architecture behind Go, like how does the dependency works. It's very interesting. It's not an interpreted language. Okay, it's a compiled language, but it doesn't resemble C or C++. It's also different from there. So it's interesting. It's interesting to read how they handle dependency. I did Go in the past, but it's a long time ago. I didn't really do a deep dive. But I know that when you do the import, you're importing from the actual URL, right? So if you have the dependency living in say GitHub, then you'll import that GitHub. What I read today is when you do that, none of the code is actually downloaded, right? None of the code is actually downloaded in terms of installing. It's just when you write a code, it's like a pointer, right? It's a link, the static link. And when you're compiling your code into a binary, that's when the code from that link gets pulled down and integrated into your code. So you can run your Go binary without installing any other things. Okay, all you need is to have Go, and then it will work because the dependency is part of your program. It's a very different way of doing it compared to, like, say, Python. Python, you have to like download the actual code, and it depends. If you use PyInstaller, you can package everything into a binary. But if not, it's a different way of doing things. Interesting, yeah. It's very interesting. All right, let's take a look at today's problem. So today's problem is filing bookcase shelves. You're given an array books. Books I is thickness and height. Thickness and height. Yeah, my cat is doing something I don't really want him to do. It's okay. Anyway, thickness and height. You are also given an integer shelf width. We want to place these books in order onto bookshelves that have a total width, shelf width. We choose some of the books to place on this shelf such that the sum of their thickness is less than or equal to shelf width. Then build another level on the shelf of the bookcase so that the total height of the bookcase has increased by the maximum height of the books we just put down. We repeat this process until there are no more books to place. Note that at each step of the above process, the order of the books we place is the same order as the given sequence. For example, if we have an order list of 5 books, we might have the first and second book on the first shelf, the third book on the second shelf, and the fourth and fifth on the last shelf. Return the minimum possible height that the total bookshelf can be after placing shelves in this manner. Very interesting problem. Okay, so we have thickness and height. The second value is height. So these, I could put, let's say 1 and 2 together, and that would be 3, right? And then we do 3. Oh, then you have 3 and 3. Damn, that's good. Okay. So you want to try DP? Does feel like DP to me. You can say what's the or you say at, or if the books is on the which shelf, right? So we have, let's see, 1 1 2 3 2 3, and then 1 1 1 1 1 1, and then 1 2. So if I have a DP table, which is IJ, okay, we say this is equal to the minimum height so far, okay, for putting I's book on J's shelf. Does that make sense? I's book on J's shelf. If we do that, we know J, the maximum on J is the total height, right? Because each book occupies its own shelf. Okay, so it's minimum height I's book on the J's shelf, right? So if I want to compute dpij, right? So I know all, if we go that, so I know everything that's smaller, right? So if I do that, I say, okay, the I's book, I want to put the J's shelf. And this I count as 0, 1, 2, it doesn't matter. So then what I need to know is, because J I'll go through from 0 all the way to itself, right? So I need to know how many books that have been on the shelf already, right? That's actually not true. Hold on, let me think again. The minimum height, because the minimum height to put first and the minimum height to put second, okay, and the minimum height to put a third book. So I can choose to put the third book on the zeros. If I put the third book on the zeros, then I need to know the second book on the zeros, right? So I need two values here. It can be min height and width. right? Width of the current shelf. Width of the current shelf. Right, height and a width of the current shelf. So I have dpij, right? So I need to look for dp. Let's say I minus 1j. Okay. Does it exist? Right, I minus 1j. If it does exist, I know the width, the current width, so I can add it there, right? And we say what's the minimum if we add it there. And then we can do a new one. So everything I will look to the previous, right? If it doesn't not exist, then we start a new one. If it does exist. Okay, so in this case, what we have 7 books. So it'll be 7 by 7, right? So it'll be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. All right. So the first book I can only put 0, 0. Right. 0, 0. That'd be 1 and 1. And that's it. Everything else will be 0. Right. So this is the book. This is the shelf. Right. So 0 on the 0th shelf. 0 on the first shelf. I can't. So these are all 0. Yeah, min, high, so these are all going to be 0. Alright. Okay, now the first book. This book. Okay, this book. So we're doing dp 1, 0. Right, dp 1, 0. So we look at dp 0, 0. dp 0, 0 is a 1, 1. So for dp 1, 0, if I want to put on the same, and then the width is 1. And my width is 2, so it works. So the width is going to be 3. And the height is going to be the previous minimum height. My height is going to take my height, because my height is bigger, so that's going to be 2. Right? And then I go 1. That's fine, right? That's fine, because the second book can take its own. And the previous one is 0. That means the height is 0. That means it can outdo. So I am the only one. So that's going to be 2, 3. No, not 2, 3. No, because it's the current shelf is that. But the total height. Right, the total height need to be. So I need to look up, right, and then to the left. Right, we need to look. Yeah, we look up and then to the left, because I want to know what's the minimum height. If the second book I put on the second shelf. Right, second book for the second shelf, I know. And the minimum height and total. So I need to know the minimum height of the first, right? I need to know the minimum height on the first shelf. Yeah, first book, first shelf. Right, so it's 1, so it's going to be 3. No, it's going to be 4, because I'm 3, so it'll be 4, and the length is 2, so it'll be 2, 4. And everything else is going to be 0. Okay. Now this book, right, I can try to put on the first shelf, and I check first shelf, the width is 3, my width is 2. Oh shoot, I think it's height and width. Height and width, this is not right. Height and width. Yeah, height and width, this is all not right. Height shall be 3, width shall be 3. And this height is going to be 4. Width is going to be 2. Right? So here, width is 3. If I add 2, boom, so I cannot do. So I cannot do. So now move here on the second shelf. So I look before. I have width is 2. So I can add 2, so width can be 4. And a height, my height is, oh shoot. Because this is the total height. So you're saying we need to record 3 values. Mean height. Can I just record? No, I don't think so. I do think we have to record. So it's gonna be min total height. Oh. Okay, let's do height, width, and then total height, right? Height, width, total height. Man, I have to redo this. This is too small. Alright, let's redo this. Okay, we need 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Book, shelf. Okay, so now that's gonna be 1 height. Height, weight. Yeah, weight, height. Let's redo this. Thickness. Okay, so it will be width, height, total height. So 1, 1, 1. Okay, so these are gone. The second one, if I put on the first, the width is going to be 3. Height is going to be 3. Okay, and total height, this is the first shelf, 0th shelf, right? If it's a 0th shelf, total height is going to be by itself, so it's going to be 3. And if we do on its own, down on this shelf, the width is going to be 2, height is going to be 3, total height, I need to look for the previous, right, 0th shelf. And that is going to be 4. Everything else out. Here, we have another 2, 3. So we look into the same shelf. So the shelf has width 3. So if I add a 2, well, so we cannot do it. So it's going to be this. Okay, now we go to the second. Now if it's in the second, we are going to check. So the width is 2 plus current 2 is 4. So width is good. Height, current height is 3. And then so current height. So the total is going to be, do I follow the previous? Because nothing got changed, right? Nothing gets changed. But if mine get back, oh yeah, so I follow the previous, so it's gonna be 4. Or by itself. If I by itself, I mean width, height is gonna be 3. And the total height, I look diagonally, so that's gonna be 7. Right, 3, 3, 1, and everything else is gonna be this. Okay, so next. Because previous is this, so I cannot put on the same. Right? This one I cannot put on the same because if I put on the 0th shelf, then it would be, so if this is this, so we get this. This is 4, so I cannot put on here. This is 2, so I can put 1, so it'd be 3. Height is still be 3, so nothing changes. Or by myself. Right, if I by myself in this hold on, 0, 1, 1 shelf I cannot do. Second shelf. Oh, second shelf. Second shelf I have. Wait, really? 1, right? So I have this. So this can put on the second shelf. So this for second shelf, I should look diagonally. I shouldn't look up. Right? Hold on, this is interesting. Here. Right, so this I cannot put on the first shelf. I cannot put on a shelf. I cannot put on shelf 0. I cannot put on shelf 1 because it's shelf 1. I look to the previous book on shelf 1. So previous book on shelf 1 or previous book. Yeah, because I need to know it's the previous book. So previous book can be on shelf 1 or shelf 2. Right, I just look the previous book on the same shelf and then say, okay, that doesn't work. Right, but the previous book can also be on shelf 0. If the previous book on shelf 0, then I already have this, so I cannot do, right? So this I cannot do. So now the current book has to be on shelf 2, right? Current book has on shelf 2. Then I look previous book on shelf 2. Previous book. No, I am on 0, 1, 2. I need to be on shelf 2. Wait, hold it. This is not right. This is shelf 1, 0, 1. This is shelf 1. Yes. All this book can be on shelf 2. Yes. So now this book comes in. I say I want to be on shelf 1, I can't. So I can be on shelf 2. So if I'm on shelf 2, right? If I'm on shelf 2, I can look at my previous book either on shelf 1 or my previous book on shelf 2. I have two options, right? I have two options. I look up or look diagonally. So if I look the previous book on shelf 2, I get a, we can get a 337, right? We get a 337. Or I look diagonally on shelf 2, which I just start a new. I can always start anew, right? I either do this or I start new, right? I start new. If I start new, it's going to be 1, 1, 5, right? Because I use diagonal to do the 1, 1, 5, right? And I say, can I do shelf 3? Right? I can do shelf 3, right? I can do shelf 3. If I do shelf 3, then it's just gonna be, because this I can do by myself, or what you can do by yourself on the fourth book, but on the third shelf. Fourth book on the third shelf, because I look above, so the previous book on this shelf, so I can do that. Or each time you can start a new one, actually. Each time you can start a new shelf. Right? You start a new shelf. Yeah, you can always start a new shelf. Always start a new shelf. You can follow the previous, or it can be a new shelf. Why? Well, we look diagonally, right? If we look diagonal, then that book can be fit on that shelf, then I can start a new shelf. Yeah. So I look up, that means we want to put on the same shelf. Look diagonally, if it exists, then if it does not exist, right, that means that book, if diagonal does not exist, that means we cannot put on a new shelf because that book is not occupying the previous row. But this won't happen, right? I'd say if this one doesn't fit, then we'll do this. Then we have to on a new shelf. Then for me, I cannot do diagonal because the previous book is on a new shelf. Yeah, if diagonal exists, I can get a new one. And then I can do, so this will be this. Now diagonal exists, so I can get a new one. This one doesn't exist, so I have to get a new one. So I get a new one. A third row will be 1, 1. Right, height will be diagonal plus 1 will be 8. Right, 4 I cannot do this. Okay, fourth book, again, top cannot do. Top cannot, diagonal cannot do. Here is the thing, right? Here is the thing. I cannot create a new one because the previous one doesn't, like, I'm on the second shelf, 0, 1, 2, right? On the second shelf. I can choose, I can still choose to get a new one. No, it's just saying that I can start a new one if the previous is the previous row, right? I can start a new one. But in this case, the previous is not a new row. A previous doesn't fit because the third book, right? The third book doesn't fit the second. If the third book fits second, then I can start a new row on the third, right? This is the first one. It's not the first one. So I just have to go up, right? Up is 115. So on me, width is going to be 2. Height is going to be 1. So it's going to be 5, right? And here is I can start a new one, right? I can start a new one. So I can be, this is 0, 1, 2, 3, right? So I can go diagonal wise, which means I add a new row, which can be 1, 1, 6, right? 1, 1, 6, or following the previous. So it's gonna be 1, 1, 6, right? 1, 1, 6. Or I can do that. Then I follow this. That's gonna be 1, 1, 9. Okay, so this again, here we have to try this. Yeah, we can do, so it'll be 3, 1, 5. Here I have two options. So either we get a new one, so it'll be 1, 1, 6, right? 1, 1, 6, or 1, 1, 6, or 2, 1, 6, right? 2, 1, 6. I prefer 1, 1, 6. We have more room, right? So we say it's going to be 1, 1, 6. Basically this, and then we get 6 a new one. Here is going to be 1, 1, 7. Here is going to be 1, 1, 10. Basically just this, right? 1, 7, 8, 9, 10. All right, the last one, no. Here we have a 1, 2. 1, 2, so we can say 4, 2, 6. All right. Here we have 1, 2, so we'll be because this will be a new one, like the diagonal wise will be a new one, so it'll be 1, 1, 1, 7. Now 1, 1, 2, 1, 2, 7, or 3, 2, 7. So I do 1, 2, 7. Basically all of this, and then I put this one at the end, right? And here, I definitely, because this is gonna be 1, 2, 8. Okay, 1, 2, 8, or 2, 2, 8. So we go 1, 2, 8. Here it's gonna be 1, 2, 9, or 2, 2, 11, right? No, it's gonna be 2, 2, 11, or 1, 2, 9. And here we have to go diagonal, so it's gonna be 1, 2, 12. Right, so what we want to know is in the last row, which one is the smallest? This one is the smallest. Okay. And now we just need to code it up. Does it have a go? Yeah, it does have go. Eventually we can transition for that. Yeah, I'm pretty sure they made this easier way. Oh, Jesus. It's gonna take a while for the implementation. All right, so books. So the length, right? So n int n equal to books.length shelf width. Okay, so what we want is a dp int dp equal to new int n. Ooh, it's n by n. Yeah, it's n by n by 3. Holy crap. I hope it won't, like, not just timeout, but oh yeah, I hope it won't just timeout. Okay. Plus j is 0, j is smaller than n, j plus plus. Okay. And we're dealing with the first book, right? So for each book we look up and we'll look to the left, look diagonally up, right? So we say start a new shelf, right? Option one, we can start a new shelf. So if we want to start a new shelf, we look diagonally if it exists. So we say if I minus 1 is larger equal to 0 and j minus 1 is larger equal to 0 and dp I minus 1 j minus 1 0 is larger than 0. Right, if this, then we can start a new shelf. Otherwise we cannot. Right, otherwise we cannot. So we start a new shelf, then int current int integer dot in max value, integer dot max value, and integer dot max value. Okay. So if that's the case, then we say we can start a new shelf. We go diagonally, and we say current 0 or equal to books I, because I is the books, right? Books I 0, current 1 equal to books I 1, and current 2, which is the total height. Each element equal to shelf width, shelf height, total height, min height. Okay, the total min height shall be dp I minus 1 j minus 1 2 plus the current height, which is the current 1, right? With height. So that's option 1. Option 2, try to fill in, right? Try to fill in the current, right? Try to fill in the previous books shelf. Okay, so if I minus 1 is larger equal to 0 and dp I minus 1 j 0 is larger than 0, okay, if that's the case, then we try to fit in the previous, right? Then, and also the width. Try to fill in the previous books shelf and dp I minus 1 j 0 is the previous width plus current 0 is smaller or equal to shelf width, right? If that is the case, then we say current 0 shall equal to math.minimum. Oh, I should have two things. Should be OP1. Yep. OP1. Right. And then I need an OP2. Yeah, I'll put it under here. This is OP2. So current, not current, this is going to be OP2, 0 shall equal to dp I minus 1 j 0 plus current 0. Okay. And OP1 is the height, it depends, right? So OP1, OP21 shall equal to math.maximum dp I minus 1 j 1 and the current height, which is books. Oh, I think it's wrong. It's not current. It should be a books I0, right? Books I0. And then this should be books I1. Right, so pick the larger of them, so OP2. And the total height shall be OP2 2. Oh, I can just do I don't have to do this. Right, this shall equal to dp I minus 1 j 2 plus OP21 minus oh. Okay, so that's the two options. Oh, my bad. We still need it. Damn it. Yeah, because I need to compare. That's okay. Integer dot max value. Oh, oopsie doozy. Put it here. Wait, what? There we go. Okay. So now, once we're done, right now we need to put it inside, right? We should say if OP1 2 is smaller than OP2 2. So we want to try to save the smallest. Right? We try to save the smallest. We want to know at this level which one give me the best option. Right? But what if the smallest here that should be fine. And dp I j 2 OP1, else if OP1 2 is larger than OP2 and dpij equal to OP2, else if OP1 with smaller OP2 I think else this will be easy. It should just be else. dp1 dpi j equal to op1 0 is a larger or equal to smaller or equal to op2 0 is the width. If it is, that would be op1, otherwise op2. And the whole thing can be because I picked the smaller of the two. Okay. Huh. If this doesn't work, so it has to be if okay. Else if op1 2 is smaller than integer dot max value. Right? It could be both fail. Right? It could be both fail. If both fail, then it's not small. Then basically I don't assign anything to it. All right, and then this I have to go through all the book. J doesn't go through all, right? J doesn't go through all because J will go all the way to I, because I cannot keep going. I cannot keep going. J will go all the way to I. Okay, so now I go through this, and at the end I will go through the minimum. So I say int res is equal to integer max value, and I say for int the last row. It's actually int might as well just int j equal to 0, j smaller than 0, j smaller than n, right? J plus plus. If dp n minus 1, j and height, total height is 2, is larger than 0, then res shall equal to math dot minimum res and dp n minus 1 j 2. Okay, now I'm gonna return res. Okay, let's try to see at least if the first one works. That is very interesting. I don't know. I don't know what happened. I have no clue. Like, what the actual hell, man? Huh? You're kidding me. Really? Okay. Yeah, we have to bring on the big gun. Yeah, it's unfortunate. I really don't know. This is one of those things. Okay, I probably just put the stop here, and then this is what? Shoot, books and shelf width. It's awkward. Why I cannot use the VF? Huh? There we go. I don't know what happened earlier. Right, and then okay, next is hold on. Let's find this. Okay. This is gonna be what? Books. Shelf with 4. Min height. Books. Okay, let's do this. All right. Books, shelf width, DP. Let's go through this. Is F8. Option 1. Don't do this. Option 2. Huh. Oh well. 0, 0. So I need to look up. But I minus 1 larger than 0 is false. Okay, so that's why. So basically I think, well, the first book is always, so I can just do dp 0, 0 equal to new int books 0. Alright, books 0, 0, books 0, 1, and books 0, 1. Alright, because that's the first, you just have to put one book in there. And then once this is done, then we will always start from 1. Yeah, we start from 1. Let's try, we start from the basic second book. So we don't have the 0, 0 situation. This one's right. Okay. Let's hope it doesn't time out. DP, where DP I J equal to shelf width, shelf height, total min height, right, when putting the ith book in the jth shelf. All right, let's hope that we can just submit it and have it pass at least one book. And we can do, let's say, oh, I've done it before. Nope. Fuck. Oh. I don't really think it's because oh wow. Okay, so yeah, it's not right. This DPID is not right. Alright, we already synced about an hour into it. We shall not continue unless you can very quickly figure out a new way to handle this. Each book, yeah, I can start a new shelf. It has to have the previous book has to be in a shelf already. Then you can start a new shelf. If the previous book is not on any shelf, yeah, that's right. You start a new shelf, then I don't see anything wrong with that. Fill in the previous bookshelf. So we try to fill in the previous bookshelf just straight up, right? And then if it has maybe we're missing a situation. Fill in the previous bookshelf. Start a new shelf. So start a new shelf has two. Start a new shelf if the previous book. Yeah, but it has to, right? Then you start a new shelf. The previous book has to be in a shelf. So you start a new shelf. Yeah. Or you try to fit in. This is the only two options. You try to fit in or you try to go out. And you try to fit in, then you have to fit in. And if you cannot fit in, then you have to start a new one. Or if you cannot, then you just skip this. You have to go to the next j. Right, you have to start to get to the next j. I don't know why. Yeah, it's with. Previous width plus the current width. Height, previous height and current height. Minus the previous height. Why is it not right? Can we have a simpler? Oh my god. 200. I don't know. Can we just. No way. Oh, am I losing the internet? What happened? Well, my internet is fine. Huh. I wonder if I have the same wrong answer previously. Oh, it's the LeetCode issue. Cloudflare. There we go. Yeah, the question is, can we, let's say, working? I don't know. Oh, this one doesn't work. Yeah, it's a fool's errand. Hint. DPI. I think I'm making the DP a little bit more complicated than it should be. It will be the answer to the problem for books I towards the end. So DPI will be the answer to the problem of books I towards the end. I towards the end. My minimum height. Okay, let's say if I towards the end have the minimum height, then we go from right to left, right? Towards the end. Now, if I have a new book, I minus 1, okay? And then I minus 1, I can create a new one, or I can try to fit in the previous row. It's the same thing, right? That's the I don't know. Books I towards the end. Okay, books I towards the end. If I have I towards the end. I have the minimum height. And I comes in. If I fit it in, or I do this. Okay, so what we're saying is this doesn't make sense, right? So you're saying 7, that's gonna be 2, right? So 6, I can say I do this, I do this, I do this. 5, I can do this, or I do this. 4, I can do this, I do this. 3, I can now do, so I have to do this. 2, I can do this, or I do this. 1, I cannot do, I do this. So that's how you're supposed to do. But why is that correct then? Yeah, what if I have 1 is here, 2 is here, right, and then 3. So I would say it doesn't fit. I'm gonna go this. I don't know. Let's see. HI is the mean height for I books. We want to find, okay. Put books J to I minus 1. What the hell is I? In a single shelf. Then the HJ is the mean height of the remaining J books. Sum of HJ and the height of the last shelf is one possibility to achieve. All possible J that placing a single shelf. Pick the smallest of such HI. So a current book. Okay. So we try to put all the books in one shelf, as many as we can. Okay, we try to put as many as we can in one shelf. So we say if these are the one shelf, then we say, oh, I think I know what this is. What's a fail? But the worst part is I don't know why it failed. Right? Use dp I to represent the mean height of shelving I books. Shelving books towards I. Right? We try to fit, right, books J towards I plus 1 in one shelf where 0 smaller equal to J smaller equal to I, right? Then the total height is dp J minus 1, right, plus current current height. We will pick the smallest. We'll pick the smallest among all these possibilities as DPI. Yeah, so it's gonna be ON squared as well, but still, I don't understand why the other one doesn't work. I don't know. Okay, so dp0 shall equal to books 0, height is 1, right? Okay, and then we need to fit j. Right, j will equal to I, int j will equal to I. So while j is large equal to 0, and current width is smaller equal to shelf width, right? Current width, current height. Current height, no, current height is 0. Okay, so I do the first, so I say current width plus equal to books j 0, right? And then current height go to max.maximum current height and then books j 1. Is it width height or height width? Width height. Okay, so I got this, and then j minus minus. Might as well just do it this way. For int j equal to I, j large equal to, yeah, no, copy this one, and j minus minus. Right. Once to get out, then we have the current height, and at each time I shall find, right? So I have the current height, and then I should say dp I shall equal to math.minimum dpi and then dp j minus 1 plus current height, right? J minus 1 plus current height. Oh, what if j do not go to 0? Does j go to 0? What do you mean by j go to 0? Yeah, j does go to 0. We're trying to fit all the books. Then what if j is equal to 0? There's no dpj minus 1. Ah, I see. Okay. So we do here, if j is equal to 0, then will be 0. Otherwise, will be this. Okay, so we can add this. Alright. If j is 0, which means we're fitting everybody in one line. So it's just going to be the current height. And at the end, we'll return dp n minus 1. Duplicate local variable, so I don't need this. Lord, it's not right. Damn, they gotta be kidding me. Oh, it was bad today. I'm missing. Okay. Okay, from 1, current width, current height, and I try to fit first book. Current width is current height, so because j is equal to 1, so we will do that. And then j is equal to 0. Well, I can move these stem thing around. Can say if that one can break. Does it make a difference? Yep. Apparently that is the difference maker. Yeah. Damn. I fail. That was bad. That was bad. That was very bad. Yeah, previous idea doesn't work. Yeah, there's a lot of retrospective I have to think about. All right. I'll need to think about it. Like, why I didn't... Like, how do we come to this one in the first place? I'll see you guys tomorrow. Adios.